Hi guys, here I am again. I just learned that I can actually move this to the middle of the screen so then you can see me. Um, so I hope you guys had a good weekend, and we are back with finishing up this pretty much this last chapter. We are going to kind of drive through this week. We've got square roots and quadratic formula is going to be the goal this week. So today, starting with some basic square roots, and then kind of diving a little deeper tomorrow, and then looking at how we can use square roots in a different way through the end of the week. So we'll be working through that quite a bit. Notes today, tomorrow, they're really short. Today is going to be a quizzes assignment, and then the rest of the week is going to be Delta Math. So I hope you guys had a good weekend. Sunday was gorgeous. Saturday I had a nice day that I could just sit and binge watch some movies, and it was great. And then today I went on, or well, I'm recording on Sunday, but I went on a nice long bike ride today, and really enjoyed the sunshine. So I'm hoping you guys were able to do the same or do something to get outside and enjoy this really beautiful weather that we had. So let's go ahead and get started and make these notes nice and short for you. All right, I'll see you later. So we're looking at square roots. So how we solve an equation using a square root. And remember, a square root symbol it looks like this. So like if we said the square root of 25. So what's the square root of 25? It's whatever times itself makes that number. So 5 times 5 is 25. So the square root of 25 is just 5. Now we also have to think about the fact that another way to get the number 25 is by multiplying not just positive 5 times positive 5, but negative 5 times negative 5. Two negative numbers still make that positive 25. So technically, by square rooting, you could have two answers that would make the square root of 25, or make that work. So 5 squared is 25, and negative 5 squared is 25. So a square root is simply undoing that multiplication process. Um, and so we are going to be looking at how we can use that to help us solve an equation. So with looking at this, we have square root equations where they're a little shorter, not nearly as much to do. They have a x squared term, and they're going to have a constant term. So they're going to have two parts. They can only be used so when there's not a middle term, so when there isn't a b in the middle, so that when there's nothing here, and or if the equation is in vertex form, which we haven't really talked about much yet this year, but it looks something like that, where it's got parentheses and squared. And we're not even going to see those today, so you don't have to worry about that. We'll talk about those some more tomorrow after we've got a handle on these first. So just to show you how they're related. So we've done a lot of factoring. So here we have looking at solving an equation. They're the same equation. One, we're going to use the factoring method, and one, we're going to use the square root method. So looking at the factoring method first. Whenever we factor, we always look for the greatest common, oops, I spelled that backwards, greatest common factor. And so our greatest common factor in this case, do we have one? Well, is there something that both 2x squared and 50 have in common? Yes, their greatest common factor is 2. They are both even numbers. So we can factor this out. We can take the 2 out, which will leave us with x squared minus 25 equals 0. Okay, so then we look at, all right, we only have two terms. Is this a special pattern? And sure enough, it is. It's that difference of two squares, difference of perfect squares pattern, where we could think about, yes, we could square root our x squared, and we could square root our 25, and that would give us an x and a 5 and a 5. And in order to make it a negative 25, we would need one positive and one negative. And now we can take both of our factors and set them equal to 0. Well, actually, we could take all three of our factors. Technically, 2 is a factor, but 2 equals 0 is not an equation. It's false, so we would just say, nah, that's not something we're going to use. We could take our other two factors, our x plus 5 and our x minus 5, and set them both equal to 0. And so then, what can we do with that? Well, we could solve that. So if I wanted to solve this, I would subtract 5 from my x plus 5, And that way I would have x by itself, and 0 minus 5 is negative 5. So there's one possible solution. Or I could add 5 to my negative 5, my other equation, so that x is all by itself, and I would have 0 plus 5, which is 5. So there's our other possible solution. So we have two possible answers, negative 5 or positive 5. If I was to plug that in into this x squared up here, if I did x squared, so if I took positive 5 squared, that'd be 25, and then I'd have to multiply by 2, so that'd be 50. Is 50 minus 50 equal to 0? Sure enough. And if I did that with a negative 5, would it still work? Would I have, if I did negative 5 squared, that would still be positive 25, times 2 would be 50, and then minus 50 would still give me 0. So there's two possible answers to that equation. So we can factor these. It's totally possible to do factoring. However, square roots do have this fancy little like kind of shortcut by taking the square root. We've seen in the perfect squares that we can take a square root to make this kind of a shortcut. So we can square root here, and that's what gives us our two groups. But we could just square root in the equation instead. So rather than having to make sure that it's equal to 0, we could move our number and solve for x just like we would on a regular equation. So I could, instead of looking for the greatest common factor first, I could add my 50 over to the other side. So I'm trying to get x by itself. And so then to get x squared by itself, I need to get rid of this 2 that's in front. So I could undo my order of operations. I could get rid of my 2. That leaves this as x squared equals 25. And then to get rid of the square term, I would have to square root both sides of the equation. So what's the square root of 25? Well, the square root of 25 is 5. But we saw here 5 is a solution, but remember there's two possible answers. 5 times 5 is 25, or negative 5 times negative 5 is 25. So we could have two possible answers. So we could say positive 5 or negative 5. You could also see it written as plus or minus 5. So that's kind of the shortcut of how we write this. So that's all there really is to it. I'm going to go through a couple of quick examples here so you can see some more different scenarios, but for the most part, that's the big thing. Get x by itself, square root it. Remember, you're going to have two possible answers. So let's take a quick look at these three. Here I can see I don't have to get x by itself. I don't have, or in this case, y. I need to simply, or I'm sorry, I don't have to make it equal to 0. I need to simply get the variable by itself. So I'm going to move my 50 over. So I have 4y squared equals 14 plus 50 is 64. And then I'm going to get rid of the 4 in front. I'm trying to undo the order of operations. So I undo addition and subtraction first. And then I undo multiplying and dividing. And then I'm going to undo my exponent. And so that would give me my square root. So I would have square root of 16, which is 4, or negative 4. So you're just going to have your two answers there. Nothing crazy. And that's really all there is to it. You get two possible answers. So here, another one, we're trying to get our variable by itself. So we're going to undo the order of operations. So we need to undo addition and subtraction first. So we're going to undo the plus 11. So 109 minus 11 would give me 98. And then I'm going to undo my multiplication by using division. So that's going to give me 49. And then I'm going to undo my exponent by using a square root. So the square root of 49 is 7. And remember, you could have positive 7 or negative 7. So you can write it as plus or minus like that, or you could write it as 7 comma negative 7. So there's two ways to write it. So then one more here. I'm going to subtract my 12 because I want to undo addition and subtraction first. Negative 8. So here we have negative 8 minus 12 is going to give me negative 20. But then when we try to get w by itself, I'm going to undo the negative 5, the multiplication, by dividing by a negative 5. And now I have a negative over a negative, which will make that a positive w squared equal to a positive negative 20 divided by negative 5 would give me a positive 4. And then I can square root to undo the exponent. And so that would give me 2 or negative 2. And there's my two possible solutions. Okay, we get two answers to a square root problem. And that's partly because our exponent is a square. The only time we would get one answer is if the answer is 0, because the square root of 0 is 0. So here, and this one says leave your answer in simplest form. So this is just saying that we're not going to get whole numbers. These are the last two real quick, just so you can see how it looks a little bit different. Still going to start the same process. I'm going to undo my, order of operations. So my 7 will go away. So I have 4a squared equals 9. And then I need to divide by 4. Now, it says no decimals, so obviously 9 and 4 do not divide evenly. So I'm going to leave this as a squared equals 9 over 4. And so what I'm going to do then is I'm going to square root just like I would. And when I do that, I not only square root the 9, but I also square root the 4. So we're going to leave this in a fraction. So the square root of 9 is 3, and the square root of 4 is 2. And so we're just going to say it's 3 over 2. But remember, there's two answers, so you would have a negative 3 over 2 as well. And there you go. All right, last one. So on this one, we're going to undo our order of operations. So we can do this a couple of different ways. I'm actually going to just undo like we've been doing. So my first step is going to be to subtract my 4. So 133 minus 4. So I have 3 parentheses, 7 plus x squared equals 129. And so then I'm going to need to get rid of the multiplication. So just like we had been doing, so same kind of process, undoing my multiplication. So the 3 in the front goes away, so the 7 plus x squared is still there. And I have 129 divided by 3. And so that gives me 43. And then I need to get rid of anything else. So I can't do my square root yet because there's still something in front of my x squared. I have a 7, so I need to subtract the 7 from both sides. So that's going to give me just x squared equals 36. And now I can get rid of my x squared. I can get rid of the exponent, undo, and I can square root my 36. So this one I didn't end up having a decimal, but that's okay. But it's a slightly different looking problem. So square root of 36 is 6, and I could also have a negative 6. So remember, two possible answers for that solution. And that's really all there is to it. So I'm going to upload a copy of the notes as well. I've got a couple of the my turn, your turn problems at the bottom. So I have some more written out examples, but it's just more of the same. So you can use those to help you out if you're getting stuck. And as always, if you need any other help, please feel free to email me, and I can help you out with those. So good luck.